Alright, 4 months is more than enough time to make you guys wait for the conclusion of my 6-gamer, 1-CPU cloud gaming rig using converted Tesla K10 cards. And it's finally working. Kinda. Welcome back to Craft Computing, everyone. As always, I'm Jeff, and we have a lot to talk about. But first, let's play a little bit of catch-up, since it's been a few months since we last talked about this thing. If you want to see parts 1 and 2 in their entirety, which I do recommend, you can click right up there and check those out for yourself. But bringing you up to speed, this is a Tesla K10. The interesting thing about this graphics card is its use of dual GK104 GPU dies, which is shared with the GTX 680 right over here. However, both of these GPU dies have 4 GB of VRAM to them each. What's even more interesting about this graphics card is that it's not a graphics card. This is a GPU compute card with no video outputs. Now, why would I want a dual graphics card with no video output on it? Well, technically, these are the same GK104 GPU cores, and you could technically play games on them. You just have to figure out how to get video out of these. Now, nVidia essentially made 2 models of this exact same card. There's the Tesla K10 that I have right here, and there's the Grid K2, which I have right here inside of this server. The Grid K2 is identical in every way, shape, and form, except for how it's recognized by your PC. The Grid K2 enables rasterization and DirectX support, whereas the Tesla K10 does not. The Tesla K10 is strictly a compute GPU. However, as these cards are virtually identical in every way, shape, and form, it is possible to do a quick resistor mod to the Tesla K10 to have it be recognized by your PC as a Grid K2 and enable rasterization support. So that solves the first of 2 issues. The second issue is, how do you actually play games on this card? The nVidia Grid series of cards were used in servers, just like this one, to create virtual machine instances that could be accessed by end users. Those virtual machines were accessed by thin clients, and then you could utilize up to the entire GPU core on one of these cards. The GPU core and memory could also be split up to 8 ways per GPU core, meaning that each of these could actually support up to 16 simultaneous discrete VMs. Now, this varies quite a bit from just straight up GPU or PCI Express pass-through, which has been demoed by a number of different channels here on YouTube over the years, probably most notably Linus Tech Tips. What Linus demonstrated was GPU pass-through, that is taking a single GPU and passing it through to a single dedicated virtual machine. You don't have the ability to split the power of the host GPU into multiple virtual machines and game with 4 gamers on a single GPU, for instance. Now, in the case of my server, I am going to basically dedicate one of the GPU cores to each virtual machine, very much like Linus did, but the core technology is, like I said, entirely different. So what took me so long to get this thing actually working? Well, it was kind of twofold. Number one, there's not a lot of documentation or experimentation with grid cards, especially when it comes to gaming and consumer level technology. And number two, nVidia kind of wants to put this whole rabbit back in the hat. When nVidia launched the Grid series of cards, it was just that. It was a graphics or compute card that you bought, installed into a server, and then ran on some compatible software. There were 2 hypervisors that were compatible with the Grid series of cards, that is VMware ESXi and Citrix Zen Server. However, it was not that long after the release of the Grid K2 that all 3 companies realized they made a mistake. Why are we letting people use this technology for free? So how did these companies solve that little dilemma? Licensing, of course. That's right, nVidia now requires you to buy a Grid license if you want to use distributed graphics card technology. Likewise, Citrix and Zen both charge for Grid licensing on their software, so you actually have to pay double licensing fees to use this technology on modern cards. But since the Grid K2 predates all of the licensure requirements, it is still technically free to use. However, getting it to work was quite an adventure. And a couple of months later, I consider myself the foremost expert on running Grid K2 cards in 2020. So for starters, there are version requirements for both VMware and Zen Server to enable your Grid K2. On the VMware side, there is ESXi 6.0 and 6.5. On the Zen Server side, there is version 6.2, 6.5, 7.0, and 7.1. There are no exceptions made to that. Now, technically, all the versions that I listed are free to use today. However, finding a download for them proved to be a little bit difficult, and you may have to sail the 7 seas to find a compatible ISO. Starting on the VMware side of things with version 6.0 and 6.5. Both of these you can download on VMware's website, however you do have to sign up for a free license, including creating a VMware account, but not a huge deal. I did install those ISOs and I was technically able to install the drivers. However, VMware never actually installed the package to let me allocate vGPUs, which means I'm pretty sure I need to still buy a license file on VMware 6.0 and 6.5 to get vGPU support enabled inside the OS. So VMware, no go. Moving on to XenServer. Now, XenServer 6.2 was the only hypervisor that I was able to get the Grid K2 cards working in when I started on this project 4 or 5 months ago. But it comes with one major drawback. When you download the Grid K2 driver package from nVidia, you have to download it for the exact version of server that you're running. So in this case, XenServer 6.2. And inside that zip file are a number of different driver files. There's a driver package for the host OS, in this case again, XenServer 6.2. There's also driver packages for each of the supported guest clients. In this case, Windows 7 32-bit, Windows 7 64-bit, and Windows 8 64-bit. Notice the distinct lack of Windows 10. Now, I'm pretty good with a little bit of Windows foo, of getting unsupported drivers to work inside of unsupported versions of Windows. However, try as I might, in this case, I just couldn't get Windows 10 to actually install the Grid K2 driver. So we are going to be stuck on Windows 8.1. But hey, I figured, since XenServer 6.2 seems to install and work just fine, let's go ahead and go for broke and install XenServer 7.1. It's on the NVIDIA supported list, and that's where even more trouble started. Installing XenServer 7.1 did allow me to install the NVIDIA drivers, and in fact in the GPU tab I could see the breakout capabilities of my Grid K2. However, setting up a virtual machine, the only option I had was to pass through the Grid K2 over to the virtual machine, and that's not what we're aiming for here. Now, according to Citrix's documentation, they removed the GUI element for actually assigning vGPUs to a VM, but you can still do it in the command line. So I ran through the whole process, got the vGPUs installed on each VM, and they refused to start because this is not a supported feature, according to XenServer. That's right, even XenServer has backtracked on allowing the Grid K2s to run for free on their OS, much like VMware. So I tried version 7.0 and all the way back to version 6.5 with the same results. So out of the 6 supported hypervisor versions that you could possibly run a Grid K2 on, only XenServer 6.2 allows them to actually work. So let's go ahead and give this thing a test drive, but before we do, let's remind you of what hardware is actually inside of here. This is a Dell R7610 2U rack mount workstation. That's right, this is not technically a server, this is the same thing as a enterprise workstation PC. Starting right up here with the brains of the operation, this is a pair of Xeon E5 2670 V2 10-core CPUs. These are Ivy Bridge chips with a base clock of 2.6 GHz and an all-core boost of 2.9. Now they may not sound like a lot, but remember we're only aiming for 1080p 60Hz gaming, so 2.9 GHz across 10 cores, well 20 cores actually, should be more than enough to achieve that goal. Paired up to our 20 cores and 40 threads of CPU horsepower is 192 gigabytes of DDR3 1866 ECC registered memory spread across 8 memory channels. So not only do we have a lot of processing power, we've got a crap ton of memory bandwidth to go along with it. Keeping everything in this box cool is an array of 6 80mm Delta blowers, and believe me when I say, these things move a lot of air. Now, when I first put this box together, I did have a fan-related problem, and that's that the GPUs are both passively cooled inside of here. And the fans were not ramping up high enough because, well, they're relying on the CPUs for temperature, and the CPUs were not getting nearly hot enough to cause the fans to ramp up. So my GPUs were actually overheating and in some cases causing a thermal shutdown when they hit 97 degrees Celsius. Now I've solved that problem, and it wasn't a software fix. If you disconnect the PWM wire on these fans, in this case the blue wire on these fans, the system will just blow them at 100%. And in the case of these Delta 80mm brushless fans, that is 12,500 RPM. So the GPUs are staying cool now. Moving on to the rear chamber of the server, we do have a pair of 1100 watt platinum rated power supplies keeping everything supplied with power inside this chassis. And this is also where our GPUs are sitting. Now I do have the NVIDIA retail Grid K2 card installed inside of here, as well as one of my modified Tesla K10s. Now, I did originally plan on having 3 cards inside of here, but that's another limitation of virtual GPU inside of XenServer and VMware, is it will only support up to 2 physical cards. So that means my dreams of a 6-gamer 1 CPU is pretty thoroughly dashed. However, 4 gamers is still totally viable. Now, what am I doing for storage to keep all of these VMs? Because again, I'm going to be powering 4 gaming machines on this one rig, and I need storage for all those games. Well, luckily, Seagate totally hooked up this project with a pair of Seagate Ironwolf 1.92 terabyte enterprise SSDs. These are going to be running in a RAID 1 and will be storing my virtual machine data. The other original plan that I had for storage inside of this box was to use an NVMe cache disk. So Seagate sent over a FireCuda 510 series 1 terabyte NVMe SSD to keep all 6 of my clients fed with data. However, there's a couple problems with using this SSD in this particular build. First off, XenServer 6.2 doesn't have NVMe drivers, so it doesn't even know this drive is installed in the system. Not that that would help, because it also doesn't support drive caching like the later versions of XenServer do. So even if we could get this to recognize, it won't actually work as a cache disk. Now, I think we're going to be just fine with that because, again, we have a GPU limitation in software. We can only run up to 4 of these machines at the same time instead of the originally planned 6. So I think the 1.92 Ironwolf drives are going to be just fine in a RAID 1 to keep all of my VMs fed with data. But I do have some other plans for both the Ironwolves and the FireCuda drive coming up very shortly on the channel, so stay tuned for that. So now, I don't think there's anything left to do but actually fire this thing up and show you how it works. Remember I mentioned those fans that I modified to run at 12,500 RPM? For some reason, my wife doesn't want me running this thing in the house. I still haven't figured out why. Do you know what's great about filming a conclusion to a video on a second day? I get to open a second beer. So what I have going on here is I have my LG 43UD79, which does support 4 inputs at the same time. I'm going to have vGPU number 1, vGPU number 2, number 3, and number 4 set up on 4 separate devices. And in fact, we're going to be using Raspberry Pis and a Steam Link to demonstrate this whole setup actually working. Hopefully. In quadrant number 1 up here, we have my Raspberry Pi 3B Plus running in the SNES case that I reviewed a little while back. And normally this runs RetroPie, but today we're just going to be running Raspbian, running both Steam Link and Parsec and demonstrating everything for you. Same's going to go for quadrant number 3 as soon as I turn that one on. That's also going to be a Pi 3B Plus. We've got a Steam Link running in quadrant 2 here. Now, the disadvantage of that is we're only going to be able to run Steam in-home streaming, but it should work just fine. And we're also going to be hooking up a Raspberry Pi 4 up to that. This is the 4GB model, and the whole kit was actually provided to me by Labis. They sell this kit over on Amazon. Link will be down in the video description if you're interested in what this kit is. But I guess they're going to be sending me over a coupon, hopefully. So if they do, I think it's good for 10% off. The purchase of this kit makes it only $90, which for the 4GB model of the Raspberry Pi 4, it's a pretty solid deal. Inside that box, we have the Raspberry Pi 4 4GB model itself, plus a number of other accessories to help us get started right out of the box. There's the USB-C power adapter. There's the micro HDMI to HDMI cable right there. We've got our 32GB micro SD. We've got a set of heat sinks for this, which I guess the Raspberry Pi 4 desperately needs, so that's probably a pretty good addition. We have a case as well as a mount for a micro little fan right there to help keep the whole thing cool. We've also got a screwdriver and a micro SD to USB adapter, so you can image your discs if you need. So pretty cool little kit. Oh, and it's USB-C as well. That's pretty sweet. So yeah, pretty decent little kit, especially if you get the 10% off. So again, I don't know if they're going to send me that coupon code. They actually sent me this out all the way back in October, back when I was originally working on this project, but then I moved. So apologies guys for taking so long to get this out of the box, but let's go ahead and put it together and get this thing up and running. All right, we are almost set up. Now you can see I've got the Steam Link ready to play Crysis right up here. We're getting the 3 Raspberry Pis fully configured. There is one thing to keep in mind with this setup, and that's Parsec has not fully updated their libraries to be able to run on the Raspberry Pi 4. So if you do want to run on a Raspberry Pi 4, you're going to have to go the Steam Link route, as Parsec just will not work. So the way we're going to do this is machines 1 and 3 are going to be running Parsec on Raspberry Pi 3B pluses. This one is going to be wired. This one is going to be wireless. Up here is the Steam Link running, obviously, Steam. And then down here is the Pi 4 also running Steam Link, and this is going to be a hardline connection. All right, so we are so close to actually giving this thing a full test. We've got 3 out of 4 fully loaded and working. For some reason, this bottom left quadrant doesn't want to launch Parsec. It won't actually let me connect to one of the machines. And I had that problem with this machine up here earlier, and I'm not sure how it resolved, but it eventually resolved. So I'm hoping we're really close, but so far, early performance is not too bad. All right, so I went ahead and compromised, and this one is now also running Steam Link. Now, I will say I was having some major issues with getting Parsec running at all on any of my machines because it was actually cutting out for seconds at a time in gameplay, and I was having a lot of just really random issues, even locally, like on my desktop PCs. So I'm not sure if the current version is just a little bit more buggy than I was used to last time, but I do have it successfully running up here in the top left. But this is 4 games running on 4 virtual machines using 2 graphics cards. One of them a Grid K2, the other a Tesla K10. So let me introduce you to what we've got going on here. First off, in the top left, I'm running Doom. Now we are in the OpenGL because the grid drivers do not support Vulkan at all. So this is Doom in OpenGL running at 1080p, and I believe it's medium settings. But so far the experience is not terrible. I do notice a little bit of latency, but it's not so bad that it's causing me any issues. Oof. Okay, maybe the latency is a little bit worse than I thought it was. Okay, there was a little bit of a delay right there. Yeah, there is definitely a bit of latency in this system. It's not terrible. I don't know that I would play a Twitch shooter like Doom. So yeah, thus far, Doom, totally, I would say playable. Definitely not the best experience. You can definitely tell I'm playing this remotely. There is a significant amount of latency in it. I would guess upwards of, okay, there's a nice glitch. That's the momentary dropout that I was talking about. Now the thing about that is that's only in the streaming setup. That's actually not happening on the PC. I've done a number of benchmarks and recording metrics like running OCAD or frame analysis, and those dropouts are not happening at the PC. Those frames are being rendered. They're just not being delivered to my remote machine here. But like I said, playable, certainly not the best experience ever. It is running pretty close to 60 FPS when it's moving though. So thus far, this one gets a solid pass. All right, moving on to machine number 2. This is my Steam Link, and we are running Crysis here at 1080p, also at medium settings. I'm terrible with the Steam controller, so apologies. Oof, wow. Am I gonna die here? I might die here. Yep, I died. I understand why the Steam controller failed. I totally get it. I totally understand why this happened. Like, you do get some fine control, but your gross control is terrible. But I will say, this is incredibly smooth. Doing the Steam Link, I've gotten so much better results than I have over Parsec in my limited testing. Although there was a little bit of a frame drop right there. Yeah, and right there too. What the crap? I swear this is on a Steam Link. Boy, I can't kill that guy. There we go. So yeah, this one's running at a pretty solid 60 FPS. Again, when I tested this in the previous video, I was able to get 60 FPS pretty regularly out of this game. But so far the Steam Link is definitely a better experience than running Parsec over Raspberry Pi. And just to prove they are, you know, both running here. There you go. Let's fire, fire again, fire again. So yeah, both of them are running. All right, on to machine number 3. So this is running my friend Pedro down here in the bottom left on a Raspberry Pi 3B+. This one is on Wi-Fi. And again, we abandoned Parsec in favor of Steam Link in this case. All right, so one thing I noticed right away is the Wi-Fi is definitely adding to some glitchiness, although I'm seeing the same kind of frame drop issues that I was in the other two. So I'm actually wondering if that's inherent to something up with the network configuration on the Dell itself. Because I was not having this issue when I tested it before, when I had it fully working before with just the one workstation. But it's been something that's been pretty consistent throughout my testing here. Now, obviously, my friend Pedro is not the most demanding of tests, but it seems to be running just fine as long as it's not dropping out its signal. I do notice a little bit more artifacting in here, some MPEG artifacting that I wasn't seeing in the other two, but again, I think that's just inherent over the Wi-Fi connection. I don't know if you can see that right there, but there's a pretty solid bit of pixelization going on across the center of the screen there. So yeah, over Wi-Fi, not the best experience in the world. In fact, I wouldn't call this one playable just because any kind of fast-moving graphics, the whole screen starts to pixelate. But I think machine performance is definitely a pass, again, because the metrics that I was recording were not dropping any frames at all. So I think the performance of the virtual machine is better than the remote experience that we're receiving. And finally, down here in the bottom right, this is the Raspberry Pi 4 hardlined, running Steam Link, and we're running No Man's Sky. Now, this is probably the most demanding title that I have up here today. We are running it at 720p, and it is struggling. I tried running it at 1080, and I was getting probably about 10 to 15 FPS. This is closer to 25 to 30 FPS, probably trending 35 at times. But again, I'm noticing the same momentary drop in frames that we're seeing on the other three, right there. So there's a good solid 1 second dropout in the gameplay, which makes this whole experience just flat out not playable. Yeah, I'm a little disappointed here, and I'm not sure how to fix that. So there we are. It works. It totally works. It kind of works. I'm definitely not thrilled with the results that I'm seeing. I think if the remote gaming system worked a little bit better, and I have tried this on PC as well, and I'm getting pretty much identical results on a PC versus a Raspberry Pi or a Steam Link, so I don't think that's the main issue here. But if the remote gaming experience was a little bit better, I think I would be able to call this a little bit more of a success. But as it sits, none of these are really playable. All of these solutions, PC, Raspberry Pi, Steam Link included, are kind of dropping out from time to time, and it's at no fault of the virtualization system. It's actually at fault of both Steam Link and Parsec. And I think there might be something buggy with the network connection. So I might revisit this on another day and see if maybe hooking up a 10 gig line and running all 4 machines off that would solve the issue, but we're only running at about 20 megabits per stream, so we're certainly not saturating a gigabit link that the systems have available to them. As far as performance, like I said, I did see an average of 60 FPS in Crysis when I tested this last time. Rocket League, we also got a 60 FPS average, but we were getting 0.1% lows in the 9s. And on the remote end of things, I'm seeing a significant amount of latency in pretty much every single game across the board. Very, very noticeable in more of the Twitch shooter games like I mentioned, like Doom and Crysis and things like that. So yeah, performance-wise, not terrific. I was able to run the Heaven benchmark in all 4 PCs simultaneously, and we got virtually identical results across the board. So we did determine that there's no physical difference between the Tesla K10 and the Grid K2 once they're both recognized as vGPU-enabled GPUs. Both those results gave us 41 FPS at 1080p medium settings with moderate Teslization, so what I would consider 1080p medium at this point. And 41 FPS, not terrific. Certainly working, but not terrific. CPU-wise, on these virtual machines, I set up 4 cores and 8 threads for each of them, and I did make sure in the core assignments that the cores were assigned to the same physical CPU. So this is on one CPU, this is on one CPU, so on and so forth. That made sure that the memory sharing isn't happening across cores and sockets, and that each system actually has physical access to whatever resources it needs. Running Cinebench R15 on all 4 machines at the same time, I got virtually identical scores between them as well, hitting about 505 CB score multi-threaded in all 4 machines, give or minus 2 or 3. Now, to put 505 in perspective, it does beat an i7 920 and 930, so out of the Nehalem and X58 days at stock speeds, we're performing a little bit better than that. However, we are performing a little bit worse than, say, an i5 3470 4-core, 4-threaded CPU, and a little bit worse than a Ryzen 5 2500U mobile CPU, which is 4 cores and 8 threads. So CPU performance, it's okay. So, sweeping conclusion time. Would I recommend this setup? No, I would not. It pains me to say that because this has been a lot of fun. This project has been insanely fun, insanely difficult as well. Getting, 7 and 8 year old technology that was never meant to work in gaming, working in gaming. And lo and behold, I was able to do it. And again, I'm in game here. I'm playing on multiple machines at the same time. And that's crazy, right? But no, this is not a viable gaming solution. Money-wise, gosh, I'm probably about $1,200 to $1,300 into the server, not including the donated SSD storage that was sent my way from Seagate. Again, huge shout out to Seagate for sending over and sponsoring the storage on this build. But I'm $1,300 in parts and memory and CPUs, and not including the second server that I bought either. So this was not a cheap solution, even though I ended up getting the graphics cards for $30 a piece. Where the money kind of snowballed in this one was getting enough memory and CPU horsepower to drive 4 machines at the same time and have enough overhead for the virtualization host to still work. So remember, we have 20 cores and 40 threads and 128 gigabytes of memory inside the server, just so we have enough headroom for all of these games to run and the virtualization server to still know what it's trying to do. That money would be way better spent on other components, on maybe buying some RX 470s for, $50 or $60 a piece, or, even an RX 460 would probably game better than these are gaming today. Ryzen 1600AF, $85, a B350 motherboard, $60 used, 8 gigabytes of DDR4, what is that, 40 or 50 bucks today? A 128 SSD and a 2 terabyte hard drive. Throw in a power supply and a case and you're done. And you have a gaming PC that can also work with all these systems. It can work with Parsec remote gaming. It can work with Steam remote gaming. This was not a smart way to go with this, as cool as it was. So unfortunately, this is where we leave you. This is the end of the Grid and Tesla vGPU solution. I've done pretty much all I can do with it. It won't run Windows 10, it won't run NVENC, it won't do a lot of the things that I wanted to do to make a good gaming PC, and honestly, I've taken the software as far as I can take it without paying for licensing for VMware or Zen Server. And even then, with these particular GPUs, we'd only get so far. We can only get so many added features because these cards are still very old and no longer supported in modern stacks by NVIDIA drivers. So thank you guys so much for coming on this journey of exploration with me. This was probably the most fun project that I've done on this channel yet, and I really hope you guys enjoyed it. If you did like it, make sure to click that thumbs up button. If you didn't like it, well, you're dead inside. Also be sure to subscribe to Craft Computing if you haven't done so already. If you do like projects like this, make sure to join the Patreon. Link is down in the video description below. That is actually how I'm able to afford to bring you projects like this. Also, the perk of joining the Patreon is you get exclusive access to my Discord server. You can chat with myself and the other hosts from Talking Heads about, well, behind the scenes projects, get advice, and join the community that's growing every single day. As always, thank you guys so much for watching this one, and I will see you in the next video. Cheers, guys. Now I want to play Doom.